Welcome to the third day morning session. So today, I got the call from Bharati Vidyapit Pune University, and they wanted that sometime solve a problem of this. So we will do the feedback first. Just 15 minutes, 10-15 minutes will take feedback. If it is not doing, then we will start our lecture. Meanwhile, you can go on. So same way like DST IGET portal we have to go, and in that DST IGET for summer institution, then there will be participating institution Mizoram University, and in Mizoram University there will be feedback link. Okay, just below the registration. When you will put the feedback link, just note down the password. Note down, everybody please note down the password. B, capital B, 2, L, capital L, small q, B2, capital B, 2, capital L, small q, and capital O.
Sir.
B, capital B,
Capital B.
yeah, then numeral 2, then capital L, then Q, then capital O.
Q is small.
Q is small, yes. Q is small, so kindly please through your mobile, and within 5-10 minutes to try to complete that one, then we will start. Because they are telling that we need to do. I tell that we welcome you, and meanwhile those who have not done, they can go or keep on doing, and because time is also running out. So before we need to finish everything, and even after 3:30 today, from 3:30 to 4 o'clock, we will have the validity session with certificate distribution. Even after 4 also, we will have a 1 hour. So if some doubt, some revision, so we will have that. With your permission, we will 1 more hour after validity also, because this is a great opportunity that two very valuable resource persons are there, and even Dr. Sulir is also there, Dr. Rao sir is there. So 4 of you, whatever in future or other things, so we will have after validity function also 1 hour visit, and we will how we can proceed further. So today just once again I welcome Madam Rajana Bora. We will be today dealing with the introduction to GPS and the global navigation satellite system. So GPS is a very important. In 60s and 70s, we don't have our own GPS. We have to depend on the global positioning system, America. America is treated like anything during that time. But now you see, we have our own systems, and now we can. This is very valuable in the development and planning. One can imagine that how we are depending from dependence to independence, and we need to further move towards the more autonomy and empowerment from individual to nation as a whole. Until unless every individual is autonomous and empowered, we cannot achieve the real facet of the development. So it is very important in each aspect, because small things in mobile also we have it. So I just give the diagram to Madam. Yes. Only one GPS is taken. 4 is with you. Okay. No. But madam is telling only one is with you, so you have 4.
You know, no problem. Is it okay?
Yeah, again only one.
One with you, I'm four with you, no? Okay, that's good.
बैटरी का क्या प्रॉब्लम है?
Okay, for vertical accuracies, for this DEM validation you're talking about, for that we need a DGPS. That's a differential GPS. So there will be two different systems there. Okay. Yeah. No, DGPS I'm not explaining. DGPS is a different system. They use it for surveying and all. It's basically used for leveling. So for this height measurements, they'll be using DGPS only. If you want to validate, you have to have a DGPS. Yeah. Yeah, if you want to validate your DEM, you have to go for surveying. There will be details. That's the horizontal accuracy. That can be checked. With a normal GPS, you can do it. For elevations, you need a GPS, but if it's only XY locations, you can use a normal GPS and validate it. Yeah. Rather than augmented system. So it basically increases the accuracy of the GPS signal. So you get better accuracy. It's 1 meter accuracy. 3 to 5 meters. 10 meter, 20 meters accuracy. SRTM Aster, the main difference is that Aster is the optical DEM and SRTM is the radar-based DEM. So if you are doing using for hilly areas, it's better you use optical instead of a radar one, because radar will be having a because the hilly terrain differences, it will be having some noise in it. Yeah, we also have Cartodem for India, Cartodem. That's optical. I think for hilly areas, Cartodem is very good. Yeah. But for plain areas, better if you use ALOS or SRTM. ALOS TM is also there. Okay. Yeah. Melbourne is already using it. Yeah. But for hilly areas, it's good. So Mizoram, I think Cartodem is good. I use Cartodem, 10 meter. Yeah, it's 10 meter. No, Cartodem is not much. Okay, 30 meter, 10 meter is only for any side. Okay, 30 meter, yeah. 10 meter data, maybe if you contact any site, I don't know, they might provide them. For research purpose, they might provide. Director. Why it is needed. Okay, good morning everyone. I'm going to take a small lecture on GPS first. After that, we'll be going to the practicals. So, do you know what is GPS? Everybody is already using GPS in your mobile phones. You all have a location button in your mobile phone, so that's actually connecting to the GPS and giving you locations. But what is a GPS? It's a navigation device. But then when we talk about GPS, Actually, GPS is something which is a US product. Okay, I'll tell you about it. GPS is mostly used for this US Navstar constellation. Whatever navigation we do using the US Navstar constellation, that we can try to say that as GPS. Everyone thinks that GPS is the same for all the countries, but it's not. They are all having different names. GPS is the US one, okay, the US constellation. But then worldwide, we are all using GPS. We all talk of it as GPS only. And the ones that we are using in a mobile phone is the GPS, okay, global positioning system. But there are other navigation systems, so that's why I've written global navigation satellite systems. It's actually GNSS. GNSS is the common term for all navigation systems, which includes GPS. GPS is just one of them. So before I go into other navigation systems, I'll just tell you about GPS in details because that is what we are coming across most frequently and we're using also. Okay, so what is global positioning system? I told you it's a positioning system, so it consists of different segments. Okay, the most important segment is the satellite segment, constellation of satellites. Then there is a control segment, and then there is a user segment. The ones which we are using, those I'll show you the receivers that we are using. That's the user segment. Okay, so this was first developed by the U.S. Department of Defense as a navigation system for the defense system, and then later on opened for the civilians. This was launched in 1978. So before that, we did not have any navigation system in operation. Okay. In 78, we had the first GPS satellite launched, and after that, from 89 onwards, the operational GPS satellites were working. And then in 94, it was fully declared as an operational program. And then what this provides is accurate navigation 10 to 20 meters. See, GPS is having 10 to 20 meters accuracy. And then worldwide coverage, 24-hour access, and a common coordinate system. So now the common coordinate system is WGS84, so it can be accessed anywhere in the world. We can use GPS for connecting to our satellite images. Whatever validation purpose we are doing, we are using these GPSs only. Okay. But then see, it has a accuracy of 10 to 20 meters. So you will have a little bit. You will not get exact location. If you want exact locations, you have to contact the military service. Okay. So now about the GPS segments. I told you there are three segments: the space segment, the control segment, and the user segment. This is common for all GNSS. The global navigation systems will have these three segments. The most important segment, the space segment, which is just a constellation of satellites. Okay, I'll tell you how it works, but we need at least 4 satellites to get the exact location because it's working on triangulation. I hope you know what triangulation is. I have a slide later on triangulation. If you have a background, you should be knowing about triangulation, how you find out locations to ranging. Okay, I'll tell you about that later on. Okay, so first that's a space segment, constellation of satellites. And then there's a control segment, which is just some control stations on the ground, which is controlling all the data that is coming and going from these satellites. And then we have the user segment, who will be just getting the output. Okay, we'll just be getting the locations and the time. Then about the space segment in GPS, this is about GPS, the US constellation, the Navstar constellation. It consists of 24 satellites in operation. There are other satellites which are kept, if there is some problem in these satellites, then they turn on the other satellites. Okay, there are some backup satellites which are turned on if there is some problem in these 24 satellites. But at a time, 24 satellites are always working. And these are circular orbits. See, you can see the picture, that is the Navstar constellation picture. So they are circular orbits at 20,200 kilometer height from Earth. And then it has repeating orbits every 12 hours. Every 12 hours there is a repetition of the orbit, and then designed for global coverage. So at least 4 satellites at a time will be visible from any station. Wherever you are, you will get at least 4 satellites, so you will get the location properly. And then now recently they are changed because it's very old. They started from 78, so some of the satellites are malfunctioning and all. So now they have started relaunching some more satellites to take care of those problematic satellites. And then about the control segment, the US, this is the US one, the US GPS that has the control segment, and the main center is in Colorado. That's the control station, the master control station. They have one master control station in Colorado, and then there's alternate master control in California. If there's something wrong in the master control, then all the work goes over to the alternate master control. There are 12 command and control antennas and 16 monitoring stations all over the world. Okay, it's spread out. You can see those points. the ground antennas, Air Force monitor station, then remote tracking monitor station. There's something nearest to India is I think in South Korea, Bahrain. There's nothing in India for US, okay? But all over the world, it's spread out. So that they can get proper locations. Then comes the user segment. So the user segment, there are two types of receivers that can be obtained from this GPS receivers. They are just radios that track GPS signals and produce position and velocity solutions. So there are pictures on the right side. You can see the first one that's used in military and spacecrafts. We don't get it for our purpose, for civilian purpose. In spacecrafts and even in aeroplanes, they have those sort of GPS receivers. And below you can see those two pictures. That is what we have. The left one, that one is usually there in cars and all. You see nowadays the cars have got their own navigation systems. So that is the same one. Okay, it's just a receiver, and that's the handheld receiver which you'll be using today. I think we are using Garmin E-Trex, Garmin Oregon. Okay, so there are many different people different companies who are taking out their own receivers. They just need to have the equipment to receive these signals. Okay, the GPS signals. So there are many different receivers. I think the prices are ranging from around 1,000 rupees onwards. You will get. Even the mobile phones have got their own GPS. But then the accuracy in the mobile phones is slightly lesser compared to the commercial receivers. Okay, then one more thing I have to tell you is that this GPS signals are of two types. Okay, L1 is the L band frequency of radio waves. There are two types of signals, L1 and L2. And the civilians like us, we only get the L1 signal. Okay. But for military purpose, they get both the signals L1 and L2. So if they get both the signals, they have better accuracy. That's why they have like less than a meter accuracy. But we only get 10 meter to 20 meter accuracies. It's written there. Signals from 4 or more GPS typically available at any time. Then who are the users of GPS? People like us. Nowadays, surveyors have GPS has completely revolutionized surveying, they say. Because after the GPS has started, we don't need to do that manual surveying techniques, leveling techniques. We have the GPS, so we can use the DGPS. I told you we can use the DGPS to get accurate heights. And then all cars, all mobile phones have got GPS now, but basically the most important users besides the military are the communication imaging satellites and the merchant navy, coast guard vessels, the navy vessels, and that is the navigation purpose. It's the aircrafts and the ships. Okay, so most importantly, they use satellites, aircrafts, and ships. And besides that, we are getting the L1 signals for us. Then, how this satellite navigation system works, the fundamentals of satellite navigation system. That was about the GPS constellation, user and control segments. How the navigation system works. Okay, a typical GPS receiver provides user position estimates to a few meters by measuring the range. So basically, it is measuring the range between the user and the multiple GPS satellites. So that this is called multilateration. Trilateration is when there are only two satellites and there are three satellites and one location. Okay, but it's basically called multilateration because there are many satellites and it's all trying to locate one location wherever the receiver is. So we are trying to find the location of the receiver with the help of the distance between the receiver and the satellite. So this is done by timing. It has to have precise timing. So time is very important because it knows how much time it is going to take, the radio wave is going to take to reach from the satellite to the receiver. So using this time and then go back to the satellite. So using this time difference, it is trying to find out the distance between these two things, the receiver and the satellite. So this is called the multilateration. There is a picture in the next slide. This is showing trilateration. See, three unknowns and three knowns and one unknown location. So if you know the distance between these three, you can find out the fourth location. Okay. So this, I think anybody who has worked with mapping and all, they know about this thing. Okay. So that is called the range. The distance between these two locations is the range. And using this range, we are finding out the location of the unknown place. Okay, so now global GNSS constellations, there are many, 4 of them are there, not many, 4 of them are global. Okay, so the earliest one is the GPS, US GPS, 24 plus satellites. After that, the Russian GLONASS. Russia has got their own GPS constellation. It's not called GPS, it's called GLONASS. Okay, GPS is specifically only for US. GLONASS is for Russia. They have 24 satellites. This was started somewhere in the 80s, 83, 84. I don't remember the exact year. In the 80s, after US GPS. After that, the Galileo, European Union, they have their own constellation. It's 27 satellites. This was in the 90s, sometime in 90s. I don't remember the year. Maybe 95 it was. You can check online. And then there's Baidu, China. This was the latest one, latest global navigation. This was in 2003 or something like 2000s. Okay. Then after that, China has got the most satellites, 35 satellites, global coverage. Okay, then we come to the regional. Those were the global satellite navigation. Now there are also regional satellite navigation systems. India has got its own regional navigation satellite system, INSS, which was first launched in 2013. And from 18 onwards, we launched all the 7 satellites, maybe one or two a year, 1 to 2 a year. And in 2018, all the launches were complete. And from 2018 onwards, all the satellites are in operation and operational mode, and we are using these for some of the military purposes. Okay, we don't use it for civilian purpose. Basically, we started this INSS. The whole idea of INSS was when during the Kargil war, why do we need our own regional satellite system when already GPS is there with such high accuracy? Basically, during the Kargil war, US shut off their GPS systems because they were in a neutral mode. They did not want to support India or go against India. So just shut off their GPS, and then we had a lot of problem doing the navigation. Military people had a lot of problem doing their own navigation. So that is why that's when it was proposed that we should have our own navigation system. Only then, in the time of a wartime and all, it will be useful because we don't know which country is against us, who is with us. So we had our idea of our own navigation system, and then 2013 this was started. By 18 it was fully operational. So now there are 7 satellites, and then Japan also started with their quasi-Zenith satellite system. This was in 2010. They have 4 satellites in orbit right now. I think there are some more satellites coming up. They are also thinking of 8 satellites in orbit. Because it's a smaller country, they don't need much coverage. So then I'll tell you a little bit about INSS because it's our own navigation system. So developed by India, indigenously developed by India. So now we are thinking if it's put on, it's not yet for civilian purpose. If it's put for civilian purpose, we don't have to depend on GPS. Right now already some military purposes they are using INSS. So it is designed to provide accurate positioning over India as well as its surrounding regions. It has a 1500 kilometer range. I'll show you the area it covers. And the space segment of INSS, those 7 constellation of satellites, the Indian constellation is called Navig. So it's given by our Prime Minister. This name was given by Prime Minister Navig. So Navig stands for Navigation by Indian Constellation. And then at the time there are 3 satellites which are located in the geostationary orbit and 4 satellites in the sun-synchronous orbit. I hope you know the difference between these 2, geostationary and sun-synchronous satellites. You know that now? Okay, so there are 7, so 3 in geostationary and 4 in the equatorial orbits. That is the coverage of Navig. It covers from 30 degrees south to 50 degree north latitudes and from 30 degree east to 130 degree east longitudes. Beyond that, we don't have Navig coverage. This is about the ground segment, that was about the satellite segment. In the ground segment of INSS, we have so many stations. We even have 2 stations in our office, NESAC. So the main control station is the ISRO Navigation Center, INC. This is in Bangalore. And then besides that, there are, that's not in Bangalore, it's in Bailalu, it's near Bangalore, in Bailalu, master control facility. And besides that, there are 2 other master control facilities in Bhopal and Hassan. And then there are many other stations, control stations, I've given the list there. 2 of them are there in Shillong also, in our office. If you ever visit our office, you can see it. IRIMS and IRCDR offices are there. That's all I think. That's all. So if you have any doubts about GPS, you can ask me and we'll go on to the practical. We'll just do a small practical on GPS.
Good afternoon to everyone. Welcome to the valedictory function of the 3 days orientation program on Geospatial Technologies organized by Department of Forestry. First of all, we would like to warmly welcome our Chief Patron, Professor K.R.S. Sambasiva Rao, Honorable Vice Chancellor, Mizoram University. Patron, Professor Lalnundanga, Registrar, Mizoram University. Professor Shiva Kumar, Dean, School of Earth Sciences and Natural Resource Management. Professor S.K. Tripathi, Head, Department of Forestry. Professors from various departments and all the participants present here today. This afternoon we have come to the end of our 3 days orientation program, and we are very thankful for it has been successfully conducted. To begin the program, I would like to invite Dr. Sanjay Kumar to give a short speech.
Very good afternoon to all of you. Very good afternoon to respected Honorable Vice Chancellor Professor K.S. Sambasiva, or I want the Chief Patron, and his constant encouragement lead to formulation of this program, because he always encouraged to have applying for the funding agency. So I got this opportunity due to his encouragement, and I applied. I welcome Professor Lalnundanga, Registrar of Mizoram University, Patron. So we welcome you, sir. I will welcome Dean of School of Earth Sciences, Head Department of Forestry, for his constant encouragement and support for this program. So basically this program is being funded by the NRDMS, DST, a wing in the DST, Natural Resource Data Management System. So one of the vision and the objective of this division to train the manpower in the geospatial technology. So they in 2 years generally they advertise this program to organize, just like a human resource development center. These also give the training program in 21-day winter summer school in various specialized and generalized field, and very basic 3-day orientation program where there is a lack of particularly awareness about such kind of the technology. So we got this program sanctioned in the month of January, and for the coordinator meet, DST call at the Pune. So I visited the Pune Bharati Vidyapit University. There we have been trained how to organize this 3-day program, and there is a specific guideline, and there is a specific portal for this DST iGet portal. If one can visit this DST iGet portal, there is a lot of information on the geospatial technology, geospatial program. There are a lot of e-resources are available, and their main focus is the open source. Means like ArcGIS is there, Radars is there, which are very costly, which cannot be afforded by the common man or common student. So now in this program we focus on the open source Quantum GIS. Now it is 3.8 version. So in this program anyone can access, easily download, access, and basic tools they can use, and they can use in various domains, from health sciences to environmental sciences, biological sciences to biodiversity application, even a developmental planning. So we in 3 days generally we focus on this geospatial technology. On first day we have a lecture from the scientist from the MIRSEC. We have a Chief Scientific Officer, Dr. R.K. Lalnundanga. So he delivered a keynote address on the overview. Then the scientist from MIRSEC again, Mr. H. Lalmanchuvanan, he delivered that what is the basic application of geospatial technology. And the same day, Dr. Subir from University of, very special guest from University of Allahabad, he delivered about the GIS and remote sensing on the open source software. Next day, we have the 2 resource person from the Northeast Space Application Center, Ms. Ritu Anil Kumar and Ms. Suranjana Bora. So they are concentrated on GIS. Morning we have raster analysis, followed by the hands-on training, In evening, afternoon session, we have the vector analysis, hands-on training. Today also, mostly means 50%, more than 50%, we have conducted the practical through the internet and the GIS lab. So major focus is to train, to make the aware people about open sources which can be easily used by everybody. So with these few words, I thank you all of you and welcome you to the valedictory function. Thank you.
Thank you, sir. Now we will have the time for felicitating our chief patron and patron. I would kindly request our Dean School of Earth Sciences and Natural Resource Management to felicitate our chief patron. Next, I would like to request Professor S.K. Tripathi, Head Department of Forestry, to felicitate our patron, Professor Lau Nandanga, Registrar, Mizoram University.
You can announce instead of you telling her she is announcing it. The basic thing is you have to understand we should not felicitate us in between. Internal people should not be felicitated by us. Only outsiders.
So I kindly request Registrar to felicitate Dr. Sudhir Kumar Singh, speaker for this program. He delivered 3 lectures, 2 lectures and 1 practical session.
You the content
Yes, absolutely.
I did not know that you are all sitting there. That's why you asked me to sit here.
I kindly request Ms. Ritu Anil Kumar to come on the dais. I request Dean School of Earth Science to kindly felicitate our valuable speaker. She delivered 1 lecture and 1 practical session. Today also whole day she has done lot of work with the student. So I request Ms. Suranjana Bora from Northeast Space Application Center to come on the dais. I request Professor S.K. Tripathi to kindly felicitate her. She delivered 1 lecture, 1 practical session, and today also she whole day she is involved in the doing the practical.
Thank you, sir. Now we will have the time for feedback by the participants. So any one of you can come up to the dais and take your time.
Hello, good afternoon everyone. My name is H.T. Desemson, belong to Department of Geology, Life Science. Yes, indeed it has been really enlightening. The only shortfall was that it was just like have a taste, but then you can find your own means. The duration was too short. Yes, otherwise if it has to be, let's say 5 days, then more practicals, and then we would have been that well versed. It's really indeed very good. So I don't have, other than that, I don't have any other complaints. That's what I have given my feedback also. Thank you.
From Department of Geology. For me, actually, I am having a bit background of GIS and remote sensing. I have been working in GIS and remote sensing from last 2 years. So, for this course, I would say it was very useful for me also, because so many things which I could not learn during my 2 years time. There are a lot of questions in my mind which I could not solve in our campus, because we have very limited knowledgeable in this field actually. So this time during this course I met a lot of research persons who are very much expert in this field. So I am having direct contact with them. If I am having some problem, I can easily ask them and then get the solution. Even whatever doubt I had in my mind, so which I had asked during this course, and these things are clear to me now. So with this, I think this course was very useful for me also. And as well as the newcomer also, those who are very new in this field, they also have a lot of idea that how can they use this software for their research work, especially forestry and environmental science. They are also now interested and going for further training courses, like for long-term courses. There are even some people that 21 days courses are also going on all around India. I am always in touch with them to give them the suggestion, because recently I have attended one 21 days course in Jamia Millia Islamia. There's some sponsored by DST only there. It was a long time, so we had learned a lot of things, a lot of modeling and all these things. So I hope that these newcomers, those who are recently introduced with this software, they can go for those kind of trainings and get benefit out of it. Thank you so much.
Let's see some women participants. Girl participant, please stand. So there is a provision for online feedback. Both programs governed by online, means even the registration also. First day we have done online up to 5 o'clock. Today also feedback also. They have feedback online. There is a category. It is being centrally governed by the Bharati Vidyapit University, Bharati Vidyapit Pune University. So they have done. But whatever feedback you have given, you can come and you can speak, because there are many problems actually online. And up to 3.
They will give complaint.
That is also.
If they feel that it is not good, they will write a feedback online.
Yes.
If you ask them to speak now, it will not be good.
If there are no more participants for giving the feedback, we will move on to the next item, that is addressed by our patron, Professor Lamundaga, Registrar, Mizoram University. So if you can kindly come up and take it.
Thank you. Chancellor of Mizoram University, Professor of Law. And the Dean of the school, heads of departments, and faculties from various departments, head of departments, and participants. Yeah, it is really great that so we could finish this course, even though some participants say that this duration is too, very limited. So this is always we are talking about. But since I'm in HRDC, the comments that we have received, most of the participants, the duration is too long. So they want to reduce the time, but this time, so you want to increase the day. Anyway, yeah, since I'm from forestry, so I know the importance of this GIS in remote sensing. During a day, so we don't have chance and opportunities to acquaint with this kind of things with GIS, because since those days, so in our course, it is not incorporated. But nowadays, we incorporate even in the forestry, and even our schools, I think most of the departments, so we incorporated GIS and remote sensing. Especially in natural resource management, it is a must. It is important that without which, so we cannot go further research, because this is one of the basic. So because of that, so while I'm doing my research and doing projects also, I'm doing projects on this medicinal plants of Mizoram. So in that also we need to have some kind of a distribution mapping of a particular species and even in a group of species. So with that, this GIS and remote sensing expertise and specialization is very much needed. So with that, so we can go ahead with a further, so in terms of this, further this research study. So I congratulate all the participants who has finished successfully. I hope that you are successfully finished the course, and we heard from the participants that you are inspired by this course, even though it is a short span, like 3 days. But it is very good that you are inspired by attending this course, that you are having a zeal of attending more duration time in this particular field. This is, I think that this is a good inspiration. Then personally, I am lucky to have again this, my old colleague, Sudhir, who has been working here, I think, how long? 1 year. Yeah, 1 year and 10 months. He is our only specialist in GIS, and he has gone, so it is a great loss for the department, but we are very lucky that at least he is willing to come back to visit the old university. So hope that so in future also he may be willing to come again, I hope. Yeah, if it is needed. So I don't have much to say. So once again, I congratulate the participants. I congratulate the organizer as well. So our Vice Chancellor has always telling us that organizing and getting a fund from different, this is a very good idea. So from his side also, this is one of the results that we could see. So hope that we will be having this kind of this course, short or even a longer period in the near future. Thank you so much.
Thank you so much, sir. Now I would like to invite our Chief Patron, Professor K.R.S. Sambasiva Rao, Honorable Vice Chancellor, Mizoram University, to take this step.
Good afternoon, everyone. Respected guests and dear participants, my colleagues, and student friends. It is a good occasion to come for a valedictory function on this Geospatial Technologies. I am not really specialist in this area to talk something about this, but I know only that ancient days onwards, this geospatial technologies are differently being used by different people. This is what I don't know whether you are being informed about this kind of technologies available in the ancient days. You remember communication through birds, communication through animals, communication through human vectors is also being followed for this kind of, even birds also takes cameras going throughout the places where various kingdoms are being ruling the particular area. They want to take photographs that also is being used. This is also, this geospatial technologies came into existence as we developed. Earlier, when these technologies came into existence, they used to send zoom cameras through some kind of small what is that they call plane, drone, and also later on through helicopters and planes also they are using. But now recently we had a very best example for us. Actually, you might be knowing when we are going to any place, new place, we are now using every day this geospatial technology. I think everyone using this. Maybe they are not knowing that this is also GPX, this is also related to this geospatial. So when we are going somewhere, I used to put in Delhi or Bombay when I am going outside, I used to put the address in that particular GPX of our mobile and go to that particular place. That is a global positioning system, it is called GPS. And without GPS, nowadays I am not going anywhere. So, even in Delhi, when I am going from airport to my place where I am actually residing, I used to keep the driver may take some other place. This is what actually I keep my GPS and go like that. No? In the back seat, I will be doing GPS and he will be having his own GPS in his car. And even the GI, the global information system, the geographical information system, which you are talking, or remote sensing, which you are talking, various techniques which are here. If you are yesterday, last week, we are seeing that Chandrayaan 2 or something, Chandrayaan 2. It is a communication satellite which has been used. And I was telling our electronics people also to apply for ISRO. ISRO has got one facility of creating the remote sensing station in any university, particularly like our Northeastern Central University, we apply. It will be definitely we get opportunity because what they do is we have a communication system with ISRO from various satellites which are being sent. And we can go through that satellite system and we can order anywhere. This particular area, Mizoram area, Nagaland area, Meghalaya area. This is the area where this kind of forest is available, this kind of forest is available. So we wanted to study. If you order a satellite image, they will send immediately satellite image. And even actually sometimes it is very difficult to analyze the images which we are getting from the satellites. So, and even remote sensing is also similarly it works, but so even remote sensing actually, I don't know what is the major difference between remote sensing and GIS. But both are same or I don't know. But in certain areas we can't get the micro level analysis in the way where remote sensing is done. If it is correct, micro level analysis may not be possible using remote sensing. Micro level means which crop is been cultured, which kind of fishes are being cultured, which kind of animals are available. Micro level analysis, is it possible through remote sensing? I think. Yes. That is images only we will be getting the remote sensing. But how you get the animals of different types? How you get in that? That is, for example, tiger is there, lion is there, or something. How do you get that information in remote sensing? I don't know exactly, but the experts are here. Maybe I think I might have spoken to you because I am not expert of this area. But it is very important that this particular technology, you have a facility for doing, exploring the various possibilities for research. For example, when we are talking about the congregation of one area, when we are traveling, landslidings and those things which we are come across very frequently in Mizoram. So if we can able to have an image system, but the present technologies will have to order the, I don't know, if you don't have a satellite communication directly, it is not possible to visualize that, I think. So you have to have a satellite communication direct linking. Otherwise, it is not possible to get the ready-made satellite images. And if you have the satellite images, I think if one of you can come forward and prepare a proposal, I can submit to ISRO and get the satellites image satellite linking station to Mizoram University. And because I have, otherwise if I have to prepare means it will take a lot of time for me to get into that and prepare that. If you can able to do that, because already we have DRDO center in our university. So if you can prepare a proposal for having a ISRO center here for satellite image connection, I can definitely get one center here in sanction in our Mizoram University. I'm sure about that. I can even write to ISRO chairman and I can get one. And even DRDO chairman is also ready to help us. So this will be helping many departments like geography, geology, forestry, and botany and other departments. No, it will be helpful to them. Those areas actually satellite communication directly if you have this, that will be very good for expanding our research. So if we can even develop all departments together, also you can have a project development. ISRO definitely will give project. I'm sure about that. ISRO will definitely give, and we can definitely get the station here in our university. That I'm sure about that. I will get it also. If you prepare the project for me, I can get within 6 months that project. I'm sure about, because I know DRDO chairman and ISRO chairman also. I know I can get it, no problem. But this commitment has to be come to a big project proposal, and also what is that we want, and we can ask them. I will definitely ask them and we will get it. It will be definitely useful for all of you to have the exploration for various things, and you can use for various animal resources, plant resources, agricultural resources, and even mineral resources, and water resources, and even I may be hopeful that even groundwater availability also you can have through this geospatial technologies, and particularly nowadays without GPX and nobody can move to any new place. This is what we are very much doing for using. So we cannot say that we are not knowing this geospatial technologies, but we know about the GPS. But only how it is functioning, how it is been acting, and it may not be known to many people, and it will be very useful technology that. But I am very much sure that many people are not been trained how to use the images. This is what actually in a short period of 2-3 days, it is very difficult to analysis part. So images can be given by anybody, but how you make the analysis? That if you get an image from any particular area, what are the components present in that? How you make analysis? This may be very difficult for anyone to make this. For this, they need a lot of training. Maybe I think more days training is required in this particular area. We can definitely try. I can even send people to Sharp Center. I can send even people to ISRO. If you are really interested, I can write to them. Because I know some people there, I can get it easily done. Remote sensing and this training and satellite image. Because satellites are now the only ultimate remote sensing or geospatial technologies which are going to be sourced in satellites. So we can definitely try through this and try to make a proposal for ISRO to have a project. I will definitely go through it and I will definitely get it done. This is what I can help. But I am not really expert. I don't want to speak more than this. I congratulate everyone for making yourself exposed for this new technologies, geospatial technologies, and you got some exposure for this. I congratulate, and I congratulate Sanjay also for organizing this workshop here.
And I would like the participants to come up on the dais to record your names. Dr. Kalidas Upadhyaya, Mr. Keshav Kumar Upadhyaya,
Pen drives also. With software?
Some handouts, we will give whatever the 3 days training program is there, we will give all these.
Mr. Nagaraj Hegde, Dr. Suresh Kumar, Mr. Sandeep Yadav, Dr. Awadesh Kumar, Mr. Vanda Tanpuya, Mr. David A. Laram Sugava, Mr. H. Lavimpia, Miss Surya Chicago Boy, Mr. K. Pung Rosar, Mr. Shija Guru Mayum Baleshwar Sharma, Mr. Etsoshan Yinga Ovum, thank you so much, sir. Now I would like to request our patron, Professor Ramananda, to Mr. Binoy Kumar Barman, Mr. Lam Hangay Zela, Mr. H. Vanda Matsom Ropuya, Mr. Wagmare Balraju, Miss K. Lam Numpui, Mr. Nurben Tangjang, Mr. Puyang Devanda Singh, Mr. Anand Janrao Deshmukh. Mr. Madhav Chandra Behera. Miss Lisa Gogoi. Miss Banu Loya. Miss Mal Songdong Zwadi Tara. Mr. H.T. De Samson. Mr. Mohit Kumar. Thank you so much, sir.
Professor Shiv Kumar, Dean School of Arts, to distribute the certificate for the resource person. Dr. U.B. Rao. Dr. Sudeep Kumar Singh.
Thank you so much, sir. Now I request Professor S.K. Tripathi, Head Department of Forestry, Mizoram University, to kindly say the word of thanks.
Good evening, everybody. So now this is the last part of the program, and this is very important also because many people they have contributed to this program for the successful completion of the event. So we need to provide a vote of thanks to people, but sometimes or always you can just miss some people because I have not been able to see how many people and who have just contributed. So if some of you are just able to forget, then please forgive me. So it's really a matter of pleasure for me to provide the vote of thanks. So we thank our Honorable Vice Chancellor at the outset. Now this is always for a continuous support, inspiration for any such kind of program. Whenever we are organizing, you are always inspiring us, and whenever you have time, you are at the station, you are trying to come up to the station and to the program, and you are encouraging us. We are thankful to our registrar sir. He has been from the forestry, he is from the forestry department, and he has been very kind for us. Whenever we are just organizing any kind of program, he is always trying to come, he is trying to encourage us. We are very much thankful to our dean, Mr. Shiva Kumar. He is always very encouraging for us. Whenever we have any kind of program or anything, whenever we are going, he is just trying to give time, and he is just trying to encourage us. So thank you, sir. Then, of course, the forestry department has been involved in this program from very beginning. I thank coordinator Dr. Sanjay Kumar, who has been working for about 2 years, I remember, to come to this event, so that he has been contacting many people here and there. Then Dr. Bhoop Singh, Head Department of this Science and Technology, Natural Resource Data Management System, who has been very kind to provide this grant to us to organize such an event. Many of our students, they have got benefited from this program. I think 32 students, they got benefited from the program. So then, faculty members of the university, especially Dr. Sudhir Kumar, he came long way from Allahabad and he has just contributed, provided guidance to our students, 2 scientists from the NISAC. We are thankful to them who came long way and who have just supported our participants. Dr. Rao has been continuously working as a resource person. He has just delivered lectures and help the students to the practicals. And we are grateful to the resource persons. So all the resource persons, if I am just forgetting anyone, who delivered the lectures and contributed to the program in any way.
Yes, public relations.
Okay. Yes, we are thankful and we have active participation of the PR cell of this Mizoram University. They have been very kind enough. They have come from the, I think, first day, and the whole day program they have recorded here, and hopefully they might have just sent it to the media also. So we are thankful to the other colleagues from the other departments, from chemistry department, geology department, some other departments like geography department. Dr. Rao is there. Many senior professors from the faculty of this forestry department, and students, especially those who come from the out of Mizoram. I think 2 or 3 students they could come. Then our own students from the Department of Forestry and some other departments. So I am very thankful to all of you. In the last, if anybody is remaining, I am thankful to them also who have just cooperated, because any program it requires a lot of effort from many people, many angles. So thank you for the great success of the program. Thank you.
Thank you, sir. With this, we have come to the end of the valedictory function. Shall we all rise up and sing the national anthem?
Subha Shishama